Nice. Let me get the YouTube running. Let's see if my bandwidth wants to allow this. This is a quantum mechanics question that came up yesterday, which I'm happy to do this one. It's actually kind of a fun one. Seeing if clickbait comes back, we can do this. Someone was asking about eigenvalues, and then this, I think, is the most recent one. I kind of want to like take a little stab at. Also, I have so many, I had so many follows just from like going around the convention, and just meeting people. It was a great networking thing just to even just get followers. Like, here, look at my feed. This is everyone who was like just following me from just going to TwitchCon. Great experience. Okay. All right, let's get that running. Someone's asking about Pythagorean triples. That'll be fun. Let's make sure this is working. Good. We got our chat. Is it just algebra? It may be. What's up, River? Good to see you. Let me make sure TikTok chat's working real quick. Sometimes it's weird. I saw someone else look like they were just coding there on TikTok. Yeah, there we go. Let's do that. Stop. And then activate again. I should figure it out. Okay, cool. All right, the Pythagorean triples, any triplet of natural numbers a, b, and c that satisfy a squared plus b squared is equal to c squared. Yes. Pythagorean triples are very, very useful. Zappy Boy says, I'm taking the peace out on Wednesday. Are there some tips you can give? Yeah, totally. Just real quick. If you go to my TikTok page, my main page here, I have a video on what I think are some important, like, quick tips to, like, speed run. This is for the SAT, which is, again, very similar to the PSAT. But here you go. Four equations to memorize for the SAT. These are kind of what I think are very important tips that will help you answer the typical questions they like to give that take up a lot of time. So that's a good one. And then here, this one, how to speed run the SAT. This is another good one that has some, like, fun tips. On basically, some of these questions, you don't really have to answer. You just need to analyze what the answer choices are, and you can quickly start eliminating things that it can't be. And then, because at the end of the day, the SAT and the PSAT is not really a test of how smart you are. It's a test of, have you done enough practice questions to understand the types of problems that they always ask and the fastest way to solve them, because it's timed, right? Unless you have, like, some nice medical condition that gets you, like, double time, and then whatever, you can do whatever you want, but don't rely on that all the time in life. So yeah, that's my suggestions, Zappy Boy. Check out those videos if you want. One of the tips I talk about in that video is exactly what we're talking about right here, which are Pythagorean triples. These come up all the time and can save you a lot of, like, headaches in trying to figure out sides of triangles and things. So, for instance, whenever you have a right triangle, okay, well, let's draw a better right triangle, like this, and right triangles come up all the time in math, in the SAT, in the PSAT, right? Because usually they refer to things like the x and the y axis, which are 90 degrees to each other. The cool thing about Pythagorean triples is they are combinations of numbers that automatically satisfy the Pythagorean theorem, which all you guys probably know, right? If this is A, and then this is B, and this is C, then A squared plus B squared is equal to C squared, right? And so a triple is a set of three numbers that satisfy this. You're a freshman. Is the SAT worth taking? No, don't take the SAT until dude, save your money, dude. These tests are expensive, right? I would wait until, yeah, I mean, if you can take it for free, sure. But you're better off taking the SAT closer to when you need it for college applications. So like your junior year, maybe, I think is probably a great time to take it. I only took it once. I got a 1420 on it, and I was like, cool. I didn't even really study for it, but because I kind of already knew where I was going to college, and I was already top 3% of my class, and that was the admission requirements at the time. So, you know, depends on what your situation is, where you're trying to go to college, but I would take the SAT closer to when you actually need to take it. If you have a free one just to get a diagnostic, like a baseline score of where you're at, sure, do it. But it's not cheap. I think it's a couple $100, right, to take it. Education be expensive, yo. Nice, Indians. Yeah, submit it, please. Yes. The queue. Oh, nice. First one's in the queue. Good. And Indians. Cool. Thank you, guys. Yep. So, real quick. Pythagorean triples are a series of numbers that satisfy this. So, for instance, 3, 4, and 5 is a Pythagorean triple. Because 3 squared plus 4 squared is equal to 5 squared. Like, these numbers fit into this equation, and they satisfy it. So, you can say it, because, right, this is 9 plus 16 is equal to 25, and, like, 25 equals 25. Duh, right? Love that.
Nice!
The other cool thing is that, like, the multiples of these work as well. So, this is what I say on the SAT, is that it won't usually be just 3, 4, 5. You may see something like 9, 12, 15, okay? Where these are all just a 3x multiple of this base triple, right? So recognizing if something is a multiple of 3, 4, 5 can also help you out a lot. The other one I say to memorize is the 5, 12, 13. After that, again, there's an infinite number of these things eventually, but you only really need to know these two and then be able to recognize what all the multiples are. Yeah. You suck at math? Uh-oh. That's a funny username, dog. Ben says, can you explain what a differential equation is? Yeah, I can later. Differential equations are just kind of like, they are equations that relate the rates of different things. So a regular equation is something like this, like y is equal to 3x plus 5, right? This is an equation that tells you, okay, if I do something in for x, what do I get for y? So that's a cool little relationship between x and y. That's just like a regular equation. In this case, it's a linear equation. Differential equations deal with the derivatives of these variables. So, for instance, if you have like xy plus dx dy y plus 5 is equal to 0. This is something that not only relates x and y in your equation, but also relates the change of one of the variables reference to another variable or just something else. Nice, yeah. Matt Tuell says, yeah, 3, 4, 5 is why I didn't need to learn Pythagorean at all, because teachers, yes, exactly. Yes, M2L, you bring up a very good point. This is what I tell everyone. Your teachers are lazy. Well, they're overworked a lot of times. So, I mean, I understand why they want to be lazy, but they design questions so that they can very easily see whether you got it right or not. And so they don't want stuff with messy decimals and fractions and radicals. They will almost always design their questions such that the triangles are Pythagorean triples, because it's an easy way for them to check to make sure they're right. Yeah, I definitely do chemistry. So there's a Q right there. So if you go to www.actualdiscord.com, or sorry, I have so many websites. They all go to the same thing. Actualofficehours.com also works. You can submit your question to the queue here, and just by dragging and dropping, and then you can see the queue so far. So I think we got 2 questions so far, and you can click on the username to see what it is. This is cool. This is a torque question. Nice. Okay, we're gonna do this in a bit. And then what did JH ask me? What'd you send me, JH? Nice. Good. This is cool. Critical points. Love this. Okay, cool. Yeah. All right. Let me see if I can do this one real quick. I may not be able to because it says challenge problem. Otherwise, JH, I'll get started right on the queue with what you guys got. This is, I do, yeah, any type of math help, yeah. Anything, anything math or science, you know. I'm sorry you tanked your calculus midterm. That's unfortunate. Okay. And then one sec. Why did this not, where's, there you go. Okay, there we go. For whatever reason, they activate the source, please. Thank you. Okay, good. Okay, now it's back. Okay, this is saying a squared plus b squared equals c squared, right? That's Pythagorean triple, and they're saying prove that this is also a Pythagorean triple. Interesting. Oh, the chat's catching up on itself. Okay, whatever. It'll figure it out. It'll figure it out. It's A line, not linear. True, Archie. Yeah. And then, yes, differential equations is a lot of fun. Canvas has been down all day, so I could not study yeah, dude, what happened, right? Amazon, like, shit the bed, right? Like, AWS, the biggest provider of, like, all web hosting, apparently just went down today. Like, they power so many things, AWS. AWS stands for Amazon Web Services, by the way, so. Yeah, Amble fumbled the ball, yeah. Oopsies. Okay. This is actually kind of cool, how this works. So they're saying this is also a Pythagorean triple. A squared minus b squared times c squared minus d squared minus 4abcd. Well, let's see. I think this, correct me if I'm wrong, Jeff, I think this like simplifies to something, right? So if we FOIL this part, that's going to be a squared c squared plus b squared d squared, right? Minus a squared d squared minus b squared c squared, right? And then we have minus 4abcd. And then you have this beautiful mess. Okay. I think what happens is it's like it's this squared plus this squared ends up equaling this squared. Is that right, Jeff? Is that kind of what we're thinking? I think that's what happens. Let's just see. If so, this isn't really a challenge problem. This is just a mess. It just sucks. Nice. Ben, just you uploaded a question. Probably next 20-30 minutes. If you can hang around. You might learn something here. Let's see what this is. 2abc squared minus 2abd squared plus cda squared. Oh, plus 2. cda squared minus 2cdb squared. Okay, cool. And then this garbly garble, right? It's just a squared c squared plus a squared d squared plus b squared c squared plus b squared d squared. Oh, Jeff says, I mean, there might be some clever way to simplify it, but basically add the squares of the first two and show it's the square of the third. Exactly, right? Yeah. So if I square this and then I add it to this squared, can we show that it equals this? Probably. But that just seems like a huge pain in the ass. Okay. I might wait on this question just because the queue's already getting pretty long. This was something submitted. Someone submitted this to me like a lot earlier. It's like a challenge thing, but let's see what the queue is right now. Questions. Wow, thanks, M. Appreciate the subscription. Okay, here we go. This is the queue so far. So 313 JH. Let's do your question real quick. Yeah, you get a fourth power. All right, Jeff, if you want to like take a stab at that while I'm helping out this one. Yeah. Okay. Consider this function. Find the critical point of f and use the second derivative test to determine if it's a local, minimal, maximal, or saddle. Cool. Great. Way to do this to find critical points is where df dx is equal to 0 and where df dy is also equal to 0. Right? These are called partial derivatives. I recommend watching on Twitch. Yeah, if you want to watch on Twitch, it's if you're on a laptop, just because the format is horizontal. On TikTok and YouTube, it's vertical, because that's just the best. I mean, that's what TikTok does. That's their format. This is Calc 3, definitely is. Yeah, so df dx is taking the derivative of this with respect to x, so that's going to be 4x minus 4. Done. Cool. And then df dy is going to be the derivative of this with respect to y. So we only care about y's. So anything with x, don't really care about taking derivatives. So this is going to end up being 2y minus 4. Excellent. And then what we do is we set this equal to 0, right? I'm like, okay, cool. Where does this equal to 0? It's the same as what you learned in Calc 1 for finding extrema. You're just finding, what's up, Panda Gamer? You're trying to figure out where the first derivative is equal to 0. Those are critical points. And then you need to classify them by a second derivative. The second derivative test in this multivariable Calc 3 land is actually called the Hessian. And we'll talk about that in a second. So 4x equal to 4. Cool. X equals 1. That's something. And then here you get what is this? Y is equal to 2. Right? Yeah, there are no mixed xy terms. Exactly. Right. Yeah. Okay, cool. So I have my critical point. My critical point is 1, 2. And then they say use the second derivative test. Well, okay. So d squared f. So actually, there's a way I want to do this, right? I think I want to do the Hessian, right? Hessian. Solve quantum fluctuations. Why do I don't want pain, dude. Wait, oh, not the Hessian in math. Actually, you know what? This was on Paul's math notes. One sec. Paul's math notes, Hessian saddle point. I do have a PhD in physics, plasma physics, specifically. So I do know a little bit of quantum. I don't really like to teach it, but yeah, I can do it. Here we go. This is what I want. This is the second order partials you need. So, let's get like fxx. Fxx is doing the derivative twice with respect to x. So this is one time with respect to x. So the second time would just get you 4. Fyy is taking the derivative with respect to y. So that's equal to 2. And then fxy is taking the derivative with respect to x and then taking it with respect to y. But in both these cases, because you have no mixed xy terms that Jeff was talking about, fxy and fyx equals 0. Cool. Okay, so then the Hessian is just this times this, because this part is gone. And you get the determinant of the Hessian is equal to 8. And okay, if d is greater than 0, and the second derivative is greater than 0 with respect to x, great. That tells me it is a relative minimum, right? Cool. Okay, so there you go. So, relative minimum. Oh, did you want me to do question B? Oh, is that specifically the one you wanted me to do? Oh, damn. Sorry, my bad. Determine the absolute maximum and minimum of f on the triangle. Yeah, there's a little bit of lag coming in. Yeah, I see it. It spiked for a bit. It says okay now. Hold out, internet. I'm killing Discord because Discord just takes bandwidth too. Stop streaming on Discord. Thank you for the rose. Okay. So, if you want to do it on the triangle bound by these sides. Oh, okay, cool. So, x equals 0, y equals 2. X equals 0 is here. Y is equal to 2 is equal to, like, here. And y is equal to 2x is here. Okay, cool. So you're saying bound on here. Because we found out where the minimum was. The minimum was at 1, 2. Is that inside my triangle? It is, right? Yeah, okay, cool. So it is here, right? Okay. And so is that the absolute? Nice. I think what you can just do is you set x or y equal to whatever you need to based on like what boundary you're looking at, and you just see what the function looks like. So for instance, when x is equal to 0, which is checking along this boundary of the triangle, I just have that f of xy is equal to y squared minus 4y, right? You can always practice. And so let's think about that. If I wanted to figure out, again, a maximum for that, if I just take the derivative, it's just 2y minus 4. And so from y equals 0 to 2, that's always negative, right? So that's always decreasing. Okay. So I think this is probably going to be the absolute minimum. This is the absolute minimum. The max, no, it's equal to 8 here. This is like f of 0, 2 is equal to 8. If I take just y is equal to 2. Yeah. I'm going to say this is the absolute max for it. You can also plug this in. Again, what you're doing is you're just restricting this equation based on the lines. So when I restricted it here, JH, on x was equal to 0, the derivative there is always negative. That tells me there's not really going to be a max here. But I know what the max would be, right? Because that's when y is equal to 2. And that's equal to 8. Okay, so we've already determined what's here. If I set y equal to 2 and x equal to whatever, you get 2x squared minus 4x plus 4 minus 8 plus 1. Yeah, it is lagging. Oh, man. Twitch. It'll sort itself. No, maybe it won't. The muon wobble. No. 2x squared minus 4x minus 4 plus 1 is minus 3. Okay. Yeah, it is multivariable, yeah. Okay, so then let's look at this. The derivative of that is just, again, 4x minus 4. Okay. So so along x, that's negative, then it's 0, and then it's positive again. Okay. So that tells me the maximum probably has to happen either here or here. So, and we already know this is at 8, so we're just going to check the endpoint here as well. And so the endpoint of that one is when, let's see, y is equal to 2. And x is equal to 2. Okay. So then that's 2 times 2 squared minus 8 plus 4 minus 8 plus 1. That's not terrible, Jeff, is it? Is it if it's unwatchable, I'll restart the stream. I'll just do it right now. Tell me. I don't want it to be unwatchable. Negative 4 plus 1. Negative 3. Okay. So this is still like... Okay. I mean, that's not like 3 minutes. Remember last time it was like 3 minutes? This is negative 3 then. Yeah, okay. Now it looks good? Okay. I'm hoping it just sorts itself out. Alright. I think the maximum is here. And I'm going to say the minimum's here. And then you're done. Cool. All right, JH.
Well done.
Good question. All right, let me pull up the next one we're going to do. 6 seconds now. Oh, it's getting worse. Okay, next question comes from Indians fan. If you have a question, submit it. The screenshot here. So I'm going to go look at the queue real quick. So right now we have 5-person queue. So next one is Indian fans. Let me see. Okay. I'll do a couple of these. I don't know if I'll have time to do all these Indian fans, but we'll see. Well, I'm not dropping any frames anymore, Jeff. So I think there's just like little spikes that happen. I think it's, again, I'm just a victim of my internet, dude. Which, okay, to be fair, I saw something really cool at TwitchCon because there are all these IRL streamers and they're always broadcasting everywhere. What they do to simplify their internet issues is they buy hotspots for Verizon, AT&T, and T-Mobile. They buy all 3 hotspots and then they share the bandwidth amongst all 3. So they have these apps that will somehow like broadcast their stream and like distribute it over the network. It's super cool. I was like, maybe that's my solution. I just start buying a bunch of fucking hotspots. Because I can't get fiber at my apartment. I need fiber. Yeah, they load balance. It's super cool. I learned a lot from the IRL streamers this weekend at TwitchCon. I was like, oh, because it was also funny. They would have these community meetups at different like times of the day, and I went to the IRL streamer community meetup once, and I could not access anything on my phone. Like, all of the bandwidth in that room was getting taken up because they're all with their selfie sticks like broadcasting. It was super fun. Okay, big band's hour hand is 2.7 meters long with a mass of 60 kilograms. The minute hand is 4.5 meters long with a mass of 100. For this problem, you may treat each... Okay, cool. Wait, whatever. Thin, uniform rod with the center mass located at the rod's geometrical center. Cool. For each of the following times, calculate the net torque that the hands exert on their shared rotational axis. Okay, well, this is easy for 12 o'clock. Do you know here that the net torque is equal to 0? And the reason for this is that, so torque is equal to R cross F, or how I like to say it, you can also say like RF sine theta, or you can say like R perp F, or you can also say this is RF perp. Yes, but the key thing is that the location of where the force is needs to be perpendicular to the radius of where it's being located at. What's up, Sid? So, in the case of the clock here... hey, Dr. G. Yeah, well, how's it going, Sib? This is AP Physics 1. It kind of is, Rastin. Yeah, it definitely is kind of like AP Physics 1. So, yeah, this is also a fun little question, because I don't know how much more of the later generations are going to understand how to read these things. Like, do you guys know how clocks work? Like, analog clocks. Yeah. So, for instance, if let's say we're at 12 o'clock, so that means the minute hand would be at 12, the hour hand would also be at 12. The forces on these hands is always the force of gravity, okay? Which is always going to point straight down, okay? The issue is that the force of gravity is parallel to the radius of where the force is acting, because the force always acts on the midpoint, or we say the center of mass of these hands. So that would be here for the hour hand, right? And that would be here for the minute hand. But then the issue is, right, is that that force of gravity points in the same like parallel direction as R. Like R measures the distance from the center of your rotation to like where the force is acting. And if they're in the same axis, then you don't have any perpendicular components. There's no perpendicular component of the force with the radius. And so also, in this case, theta would be 180 degrees, and sine of 180 degrees is 0. I do teach AP Chem, yeah. Yeah, if you have a question, submit screenshots. Screenshots, that's how you do it. Okay. So do we understand, Indians fan, that's why 12 o'clock is 0? Three o'clock's probably a little bit more fun. Cool. All right, let's do 3. Okay, so at 3 o'clock, you have the hour hand pointing here towards 3, and then you still have the minute hand pointing straight up, okay? So the torque from the minute hand is still going to be equal to 0 because it's still just pointing straight up. You need it to have some component that's perpendicular to the force. When will I finish streaming? Another 2 hours. Yeah, 2 hours. 2 hours, I'll finish. I should put like a little timer on like estimated time for office hours end. That's a good idea. I should do that. Okay, so here on the hour hand, you have the center of mass, and then you have the force of gravity due to that. And then this will have some sort of torque to it, right? This will equal to the distance, which, what do we say? The minute hand's 4.5 meters. Okay. So that's going to be equal to 2.25, sorry. That's half of, that's the midway point. And then times the force of gravity, which would be mg. So that's 100 times 9.8. And then, again, if you really want to, you could say this is sine of 90 degrees. But whatever. Key thing here, also, torque here is technically negative. So when we talk about positive and negative torque, the convention is that counterclockwise is positive and clockwise is negative. So since this thing is trying to, again, pull the hand clockwise, the minute hand's trying to get pulled clockwise direction, technically torque is negative. The hour hand is shorter. Oh, sorry, Indian fans. Sorry, I picked the wrong one. Sorry. I did it for the minute hand. Yeah, you're so right, dude. Okay, my bad. It happens. Sorry. Thank you, Indian fans. Yeah. This is 1.35. I did the wrong hand. Why do they have the hour hand coming first in the question? The minute hand should come first in the question. Okay, well, this is 30. Yeah. Good catch, though. Or, sorry, the minute hand caught... No, the hour hand is 60 kilograms. Okay, good. Okay, there you go. What were you saying about young people not being able to read time? Well, in my case, I can't read, like, the question. Or I assume it's in an order that it's not. Yeah, Jeff. Yeah, you're good. Yeah, you got me. He got me, Jeff. Okay. Where it gets harder, right, is 7 o'clock, for sure. 7 o'clock is definitely weirder. So, in the case of 7 o'clock... Ooh, man. I gotta think about how clocks work. This is 6, right? So 7's gonna be, like, right here. And then we're gonna have... Again, the minute hand will be straight up. I don't care about that. It's just the hour hand we gotta worry about. Okay. So, in this case, I need to figure out what the angle is. And so, if there are 12 numbers in 360 degrees, right? So, 12 hours is equal to a full rotation. That tells me that 1 hour is equal to 30 degrees, right? 6, 7. Oh, no, dude. They got me again, dude. You guys got me, dude. You got me. Okay. It became... Even though it's not at 12. Yeah, exactly. So, yes. 6, 7 lives again. But this tells me this is 30 degrees. Okay. So, I like to draw kind of a little dash line here, right? This is 30 degrees. Okay. So, when I'm computing torque, this is going to equal to the radius, which for the hour hand is 1.35. Well, to the center of mass, right? And then we're going to say the same 60 times 9.8. And then we're going to say sine of 30 degrees. Yeah. Yeah, not cosine of 30. It's got to be sine of 30. Because gravity points straight down, right? This is the force of gravity. So if I want the perpendicular component of that, right? And let's say again, this is 30 degrees. The perpendicular component to the radius is opposite sine of 30. Will it be negative as well? No, in this case it'll be positive. Reason being is that if gravity's pulling it down this way, it's technically pulling it in the counterclockwise direction, and counterclockwise is positive for torque. So this, we know sine of 30 is equal to 1/2, right? So then, and then this will be positive. Okay. Okay, this is the extra silly one, which is at 9:15. Okay, let's do 9:15 real quick. All right, 9:15. Interesting. So now the minute hand is going to play a role. So the minute hand, which we said was green, I guess, that'll point here, right? To the 3 technically, which is 15 minutes. So we can calculate the torque from that. So this torque is going to be equal to the 2.25 times the mass, which is 100, times 9.8. And then because this is pointing left, right, but gravity's pointing up, down, it's really sine of 90 degrees, so it's just 1. Okay? Right here, I'll put sine of 90 just in case. And then you got to think about what is the direction. This is where direction does matter, okay? So if gravity is trying to pull this down, that means it's trying to pull it in the clockwise direction. And clockwise directions for torques are negative, okay? So this is going to be negative. Okay, but now we got to think about the 9 o'clock thing. So this is actually kind of fun. So if it's pointing towards 9, it's not pointing exactly at... If it's at 9:15, it's not pointing exactly at 9. It's like technically a little bit up, right? This is kind of the wacky thing, right? So for instance, this would be 9, and then I don't know. Let's say this is like 10 o'clock. Okay, 9:15 is going to point because the hour hand moves as the minute hand moves around. So technically, the hour hand will be a quarter of the way in between 9 and 10. And the reason I know that is because the minute hand being at 15 minutes is a quarter of a way through the hour. Exactly, Indians fan. Yes, so this is going to be located. And because from before, right, we said every hour was 30 degrees, because 12 hours is 360 degrees. That tells me this must be a quarter of 30 degrees. So 30 over 4 equals 7.5 degrees. Excellent, good. Okay, so this torque... is going to equal the 1.35 times 60 times 9.8 times the sine of 7.5 degrees. And then since that's trying to pull it this way, which is counterclockwise, this will be positive. Excellent. Okay, cool. So your last step is here. Just add this. And then subtract it from this, and that should give you the net torque. No, it's still sine. It's always sine. Reason being, Jeff, no, it's sine of 7.5 degrees. Because R, right? So the force of gravity is pointing straight down, but R is pointing is pointing this way. And so I want the amount of this, which is perpendicular to this, right? The equation's always sine. Yeah, I mean, it's always sine if theta is the angle. So at 9 o'clock, it would be sine of 0, correct? Yeah, totally. Because it's always the angle. No, it would be sine of 90. What's up, FemVox? Be sine of 90. Okay, you are right. Technically, it is like 97.5. No, torque isn't that hard, honestly. Yeah, but wait, isn't the sine of 97.5 the same as the sine of 7.5? Because sine is symmetric. It's not? Well, Well, okay. I know I want the amount of this, which is, double check, but no, he says. Wait. Maybe he's right. Give me a second. Oh, you're right, actually. Sorry. No, you are right, Jeff. I made a mistake. It is 97.5, because that's this total angle through here. Yes. Thank you. Yeah. Sorry, I meant 82. Yeah. You're right. Yes. You know what I was doing? I was trying to figure out the parallel component instead of the perpendicular. You're right. This is 97.5. All right, let's show why. Yeah. You don't want the amount of this which is in the direction of this. You want the amount of this which is perpendicular to this. So that would be cosine of 7.5, right? We agree with that? So this is what I call like R perp, right? And then this is to gravity. Again, because it's either R perp F, which in this case, everything math and science, middle school through high school. mean, well, biology's kind of a weird thing to like tutor, but yeah, but chemistry, stats, I don't care. Math, physics. So this would be r cosine of this angle, right? Of 7.5. That would be equal to r perp, and then you would times it by mg. Yeah. So in this case, it actually would be cosine, but if you want to get, if you want to just always have the same consistent equation you're using, technically this is the angle that you need to use for sine, and this is sine of 97.5 degrees. Yeah. Because it's 7.5 degrees further than just being sine of 90. Jeff's right. Okay. Does that make sense, Indian fans? Yeah? And then just you know, do the calculations on your calculator and just cancel. Yeah, you just messed up the R. Okay, all good. Nice.
Well done! Well done!
Nice explanation. Thank you, dude. Appreciate that, Baka. All right, let's go look at the queue. So we just did Indian fans' question. So I'm gonna mark that one as done. Next one's Emma. And we got No Scope, Ben, Jeb, and Ari. Cool. Oh, it's Joe? Okay, cool. Yeah, let me add you. Joe. Dingler? Is your name Dingler on my Discord, dude? Joe Dingler? Is that some meme or something? All right, let's see. All right, Emma, what do you got for us? How many molecules are in 0.5 moles of calcium? I like this, Emma. That's actually a really great one. Yeah, it's cool. People kind of like don't really understand like moles and molecules, and I mean they all kind of look like the same thing sometimes. Joe is not my first name. Yeah. Okay. Cool. All right. The key thing here is like moles is kind of the same thing as saying like a dozen. People always get like kind of confused, like what does a mole mean, right? So 1 mole of like blank, it could be a mole of Labubus. I don't fucking care what it is. That's 6.02 times 10 to the 23 things. Exactly. This is chemistry. Yeah, I teach chemistry as well. I teach all math and science. Anything math and science, middle school through college. It is stoichiometry. Yeah, exactly. Avogadro's constant. Yeah, exactly. So if you want to say 0.5 moles of calcium, that's interesting. They say molecules. I would say like atoms, right? Doesn't molecule imply like multiple atoms usually? Yeah. So yeah, and I always like to do stoichiometry this way. So I'll say like question mark, what am I looking for, right? Like how many molecules? And then equals to, and then what are we starting with, right? So I'm starting with 0.5 moles. Yeah, that's okay. Statics is fine. I mean, I'll try it. Nice. I'll tell you real quick whether I can do it or not. And then, right, yeah, 1 mole is equal to 6.02 times 10 to the 23 molecules. I want to say atoms. So yeah, the correct answer there would be 3.01 times 10 to the 23 molecules of calcium. Solid, yeah, exactly. Yeah. Oh, fluid mechanics and hydrology, maybe, Logan? You can try submitting it. I can tell you if I can do it or not. When we start getting to kind of the more specific engineering questions, I just don't know the jargon. They use like really specific words for certain things that, again, I know the concepts work in physics, but we use like pressure, force, and area, and then sometimes they start saying like, I don't know, like somebody's constant of something, sheer tension, stress, or something. Yeah, thank you for doing these live. Yeah, you're welcome, random user. Okay, cool. All right. So yes, that's how you do that one. I'm trying to think. The other question that comes up, Emma, I'm just gonna say real quick because I'm teaching other students in this field like the same stuff. They would do something like this. They would say like, how many molecules are in like 3 gram? How many molecules? Or here's what they would say: how many atoms of hydrogen are in, let's say, like 20 grams of water? This is a really good one that comes up sometimes. Okay. So let's remember that water, right, is H2O. And we're going to start here with question mark atoms of hydrogen is equal to... Oh, 3 seconds? Yeah, no, it's funny to see the coincidence. So 20 grams of H2O. Okay. Anytime you're trying to get into atoms, what we did here, right? Getting to like molecules, atoms, particles, whenever they say stuff like that, you want to get it into moles somehow. So I need to go from grams here to moles. And specifically, there's another key thing here, which is we're asking for atoms of H, which is a different species than H2O. These are 2 different things. So in chemistry, when you have 2 different things you're trying to convert between, you need to put it into moles first and then do what's called like a mole ratio. And I'll show you where that comes up. So the first thing you can always kind of like bet you're going to do is you want to try to convert grams of H2O into moles of H2O. And the way you do that is by looking at what's called the molar mass, right? Which I think is 18 for water. Yes, it's 18. Cool. So you can say here, okay, cool. Well, 18 grams of H2O is equal to 1 mole of H2O. And then here's a tricky thing, though, right? Because I want atoms of H, but I'm given grams of H2O. So I need to relate H2O to H. And we do this by a mole ratio. So what I'll say here is that 1 mole of H2O is technically 2 moles of H, right? Because for every 1 unit of H2O, I have 2 units of H. I like to think of this also like, say you're in a car, right? Every 1 car has like 4 tires. So if I have like 3 cars, I have 12 tires. Cool. And then once you're at moles of H, this is where you can then say that 1 mole of H is equal to 6.02 times 10 to the 23 atoms of H. Okay? And then you're done. And this is, right, just multiply all through the top, multiply all through the bottom, divide out, and you're great. Cool. If I were teaching, I would put the units before putting the number. I just think it's easier. Yeah, I love dimensional analysis as well. The units before putting the number, I kind of do that, right? Or you're saying you would say H2O and then you would say grams? I guess it works. I mean, this is the common way we do it. So much of being good at science is just being able to do unit conversions. 100%. Definitely agree. Yes. Rashid, if you submit a question on thermochem, I'll do it. Yeah. Yes, you're very welcome, Emma. I'm glad that helped you out. Oh, I need to be like, ooh, this is what I wanted to do. I forgot. I want to put all these questions into our Discord while I do these. I forgot I was doing that. Here, let me download this. So this was, I think this was JH. Let me put his in. New post. Right, so if you haven't joined our Discord yet, I highly recommend you do, because this is where I will post the screenshots of the questions that I've already done on the stream. So this was JH's question. So we're going to post that one. And then this one was Indiana fans? What team are the Indians? Isn't that like the Cleveland Indians? Like the baseball team? forget like what team hasn't. This is Indian fans. Hasn't had to change their name yet or something. Like the Commanders, right? Okay. Can you replace your question really quick? If you're next in the queue, yeah, you can tell me. It's okay. Okay, that was Indian fans. And then this one right here was Emma. Okay, so let's get Emma's. Sorry, I meant to be doing this. This is a new thing that I've started doing because we're getting so many questions, which I love. Thank you for all the questions. But I want to create like a way to organize like where they all are. Also, so if you guys want to go back and like learn from it, you can kind of see later. Cleveland Indians, they changed their name. They're Guardians now? Really? That's fucking whack. Damn it. Yes, Atlanta Braves unchanged. Yeah, good. Yeah, don't change the Atlanta Braves, dude. That's like forever, dude. Okay. All right, that was Emma's question. We did that one. So let me go mark it off on the queue. No scope replaced his question with this. Okay, cool. Ooh, we're doing ham radio stuff? This is fun. Dun, 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 dun. Is it FM radio? Well, I guess, yeah. Frequency modulated versus... Okay, here we go. A radio station... Okay, cool. This is, yeah, very intro kind of physics, but it's also good. So what we learn is that the speed of a wave is equal to the frequency times the wavelength. Okay? Radio waves are called electromagnetic waves because they travel with varying electric and magnetic fields, and those travel at the speed of light. Okay? So the speed of a wave in this case is going to be 3 times 10 to the 8th, which is the same thing as c. So 3 times 10 to the 8th meters per second. Yeah, this is the fastest thing in the universe. Nothing can go faster than it. The frequency, cool. So that's 97.4, and then mega is times 10 to the 6. So I'm going to say it's like times 10 to the 6. And so now all we need to do is solve for lambda. So let me get my calculator out. Like, it can't be silver though. Where's my gold calculator? There we go. Cool. All right. So if we pull up the calculator here, you go solve that, right? That's going to be 3e8. That's how you type 3 times 10 to the 8th in the calculator. And then we're going to divide that by 97.4 e6. Okay, and that's going to give me a wavelength of 3.08 meters. Cool. So lambda is equal to 3.08 meters, no scope. But they're asking for the aerial needs to be equal to half the wavelength. Cool. So half the wavelength would then be equal to, so 1/2 lambda, which is equal to 1.54. Nice. Yeah. Right? Ariel, this question is from the 80s, yeah. Yeah, one sec. TikTok always wants to make sure I'm being a real person. There I am. Oh, Sir Giggle Touch says, I saw you the Red Bull section at TwitchCon. Yo, what's up, dude?
That's dope.
Bro, I was just saying how fucking blessed we were to have Red Bull have that installation at TwitchCon. That thing saved my life. Like, no lie. I was struggling so much at the end on Saturday. I really needed, like, some caffeine. And bless them, Red Bull, for just providing infinite unlimited amounts of free caffeine, plus like food, dude. Like, we got Nobu sushi Saturday night. I went back Sunday afternoon because I was like really hungover, and they had awesome tacos, and like ice cream and churros. So many good things. Yeah, cool to see you, dude. The pancake maker, yeah. The pancake maker was super cool. Dan Cakes, Dan's Pancakes or something. Yeah. Nice. The full gold suit. Yeah, I wear a lot of gold. There's a whole theme here running. Yeah. Very cool. Okay, cool. Yeah, no scope. You said that's correct. You did. Okay, cool. Awesome. Great. Love it. Sir Giggle Touch. Who were you? I met so many people that night. I'm sure if I go into your stream, I'll go find it. But we met at the pancake thing. Were you one of the IRL streamers up there with I was just talking to my chat about how one of the IRL streamers showed me how they had 3 different hotspot modems all distributing their stream. It was super cool. Oh, on Sunday. Okay, cool. Panda Gamer says, I'm Ben from TikTok. Cool. All right. Nice. Random Kid. Oh, what's up, Random Kid? Nice. Yes. If you want to, hey, Giggle Touch, if you want to, like, ever ask any, like, math or science questions, please feel free to, we have, like, a whole, like, screenshot system here where people can, like, put in their username and, like, drop in, pictures of homework questions they want. So, for instance, these are some examples of questions that students have been asking. It doesn't have to be super advanced. I do everything from middle school all the way up through college. So more than welcome to do that. Also, if you join our Discord, we have a whole like gamified system there where you can earn points for just doing regular cool stuff in your school. So for instance, we have a, what's it called? There we go. We have like the good grades challenge. So here, like, students will show me, oh, you did, oh, great, this is awesome. You already did it. Okay. You already understand what to do. Great job, Giggle Touch. I will give you points for that. But yeah, for those of you watching, we're an official nonprofit, and we help students feel more motivated to do well in, like, math and science because we give out, like, V-Bucks and Robux and all sorts of gaming gift cards for students doing, you know, productive things that advance themselves in school and in life. So, yes. Red Alert, Canvas is back online. Yeah. Yeah, awesome. Good, cool. All right, well, hang around, Sir Giggle Touch, if you want to just, like, we're going to do all sorts of other, like, math and science questions today. So, next one is Ben. And then, wait, let me put this on, I want to put this in the thread. Let me do it real quick. So, this was this. Yeah, for sure, Haka. Yeah, no, it's cool. Yeah, we like to give back to the community, you know? And I had a really great time, like, meeting a lot of other awesome streamers at TwitchCon that also do kind of like charity type stuff. And I was like, hell yeah, I'm about that life. Happy Diwali. Oh, is it what do they call it? Is that like India New Year or something? Okay, we did this one. So, let me mark no scopes done. Done. And then we'll clear number 5 as well, because that was your replacement. So, Ben. Let's see what you got, Ben. What do you got for me? Oh. I definitely do E&M physics. Yeah, for sure. I mean, I taught E&M physics this summer at UCLA, so, like, I can definitely do E&M physics. It's a Hindu festival. What's up, River? Okay, so this is it. Determine the slope and displacement at C. EI is constant. Use consistent units. Use the moment area theorem. Well, it's in... Oh, man. E equals to KSI. Isn't that like some famous streamer? KSI, right? Yeah, this is engineering stuff. I know where we're going with this. I need to look up stuff. Because these are just like weird units. So for instance, like I'm not exactly sure what EI is. When I see K feet, this makes me think of like torque, but then they use weird things called like moments. Oh, K inches per, yeah. Square inches, yeah. Kips. EI is stiffness. So I'm learning things I'm learning alongside with you guys because I have never seen this stuff before. Yeah, what is moment area theorem? Oh, okay, so KSI stands for kilopound per square inch. Wow, very cool. All right, from what I see, we need like shear and moment equations. What is sine of pi over 2 is equal to 1? You should know that. Come on, Alistair. And then use conjugate beam theory. Use the method. Dude, what? What is this stuff? Dude, engineering goes too far, dude. Like, what? Why do they come up with all these goofy names for things? The conjugate beam theory? Oh my god. Okay, so here you basically use that the curvature of the displacement function is equal to the negative bending moment function divided by the stiffness. Oh, man. My PhD is in plasma physics. So, again, all of this stuff comes from physics. But engineering just puts all these goofy names on it. And then they start coming up with these weird equations to, like, make things simpler. This can all be just solved with physics, but they come up with these alternative metrics and names for things, which is like boggle my mind, dude. Like, what? Virtual work? no hate, dude. No, it's okay. And honestly, like I love hate anyways. It's great for metrics. So I would say my haters get me to the front page. But yeah, no, totally. Okay. Yeah, there you go. Engineer is dude. I bet more the engineer. Yeah, I don't have an engineering degree. I have a physics degree. But okay, let me see if I can try to do it. I want to like try to understand it with you guys. Like, what does EI stand for? What does EI stand for? And E is that, I is that. To me, this looks like a moment of inertia, right? I'm just going to try to understand this from a physics point of view. This looks like moment of inertia. That's what I usually is, right? First two letters of Old McDonald's farm. Initial electronegativity. No, there's no way this is electronegativity. And I do agree momentum is a rotational force around a point, which moment is just torque. EI is like stiffness. And then so what is E? Here, Fembox, do you want to like do you want to attack this one, Fembox? And like just send me a screenshot of it and then I can like try to understand it. I've never seen a question like this. Yes, moment is a torque. I agree moment is a torque. Yeah, I mean that's what I see here, right? I see there's a torque from this, right? This I guess is also a torque. But so this tells me automatically, I think, what the mass of the thing is, right? E is a materialistic property. Oh, okay. Modulus of elasticity. Yeah. Engineer Ismail, yeah, if anyone wants to see the original question, okay, so when you go to that website where people are submitting their questions here, like submit your questions office hours, if you click on the live queue here, you can then see it's Ben's question. You can click on Ben and it'll pull up the image for what he submitted. Yeah. So here's what I'm gonna do. I'm gonna pass on this question just because I've never solved anything like it in my life. But I will challenge someone in my chat to come up with a solution for it. And if they want to post it or send it to me, you can also join our Discord right here and post the solution in homework help. I'm going to drop it in homework help right now for you. So, because I'm not going to be able to figure this out. And it's totally okay. We are all human, you know. Okay, so I'm going to say this was Ben S. I'm going to drop the screenshot in. And then, you know, I will... here, I'll run it through ChatGPT because I pay for it. And I'll give you what ChatGPT says. And you can kind of like just try to... if that helps. But I'm hoping that someone here in my chat will just kind of write something up and go do it. And how about this? If you do it, I will reward you with something. So it's right here. It's in the homework help. It's under Ben S's. And then here's the question. Here's what I have ChatGPT saying so far. So if you'd like to post, your own little solution for it. I would love, yeah. Alistair says you can do it. Cool. Great. Yes. And honestly, that's the beautiful thing about the internet is that, again, I'm streaming. You can see this. There are 3 different platforms right here. We got TikTok, we got Twitch, we got Discord, we got YouTube. I love that there are enough engineers watching my stream right now that y'all can maybe help this guy out with a very specific engineering question. Again, I've never seen before. But cool. Y'all the best. Okay, go to Discord. Yeah. Good, Cocta. Appreciate it. Okay, so I'm gonna pass on that one. But good. Thank you, Ben, for submitting it. I love getting the community involved with helping things. Next question is from Jeb. Ooh. Establish the algebra rules for gradients? What are we doing here? Alistair says I'm a fourth year engineering major. I can do it no problem. Sick. Okay. Well, both of you guys want to do it? Cool. Let's see if you all get the same answer, right? That's always kind of fun too. Given a constant k and the gradients here, establish the Discord link's not working? Oh shit, really? No, it should be. Wait one sec. So if you go to here and you click join our Discord, it should pipe you. There it goes. It should definitely send it to you. I can also do this. There you go. Panda Gamer. Yeah, actual EDU, that one doesn't work. Wait, this one should work as well. No. It seems... You tell me if it's not working. I thought I set that Discord link to never expire. Because that link has like 300 invites on it. It's nuts. DM's Grader says, if they get different answers, it'd be like the 2 smart kids getting different answers. Yeah, no, I'm curious. I'm curious to see if they get the same answer. It'd be kind of fun. Okay. So someone's asking about, what is this? The algebra rules for gradients. So like whether you're allowed to add or sum gradients. So, oh, like, can you, okay. They should, yeah, we'll see. I mean, correct me if I'm wrong. This has to do, like, for instance, are you allowed to do this? Am I allowed to say, like, gradient of f plus g is equal to gradient f plus gradient g? This is kind of like an algebra rule, I guess, which I don't think you're allowed to do this. Or maybe you are. Alistair said he already got part A onto part B. Wow. Wow, okay. He's working fast for you, Ben. Okay, let's think about this like component-wise, like what would happen, okay? Okay, so F is composed of like some X component, right? Or no. Yeah, here's what I want to say. Derivative should add. I think you're right, actually. So let's think about this. So let's think of what nabla F plus G would be equal to, right? So F plus G, let's say, for instance, f of x is equal to, like, I don't know, like 3x plus, or no, so it's f of x y z, right? It's a 3D or 3-dimensional, 3-variable, whatever. Okay, all good, Abdallah. I mean, if we get to it, I'll just do it and post it anyways. Let's say, for instance, fxyz is equal to, like, 5x plus 3y plus, I don't know, like 4z. Right, and then let's say, like, g of x, y, z is equal to, I don't know, like 6x plus 2y plus 8z, okay? If we were to add the two functions together and then do derivatives, okay, cool. So f plus g would be equal to 11x plus 5y plus 12z, okay? So then the gradient of that,
nice.
I like to just see, like, if it works, and then I can kind of see if it works in general. That would be equal to like 11, comma 5, comma 12, right? Well, let's see individually what grad f would be. Grad f in this case would just be 5, comma 3, comma 4. And then grad g in this case would just be 6, comma 2, comma 8. If you add those up, do you get the same thing? Yeah, 5, 6, 11, 2, 3, 5. Cool. Yeah. Yeah. So, I think the derivatives do add, actually. Okay, so I'm wrong about this. Sorry. So, this is equal to grad f plus grad g. So, I agree. That's cool. Exactly. Jeff says when taking ddx of, or yeah, dd, or whatever, partial x, it's just like a function of one variable with y and z being constant. Yeah. Yeah. Okay. So, yeah, that's what... I agree with that. And then by a constant, right? A constant shouldn't change anything. So I would think that nabla, for instance, kf should also equal to k nabla f, right? Because derivative rules allow you to just pull constants out all the time. That's fine. What's another one we could think about? So, okay, this will be like adding and subtracting, so we'll say like plus minus. Ooh, what about multiplying? Ooh, I like this one. What about grad of f times g? Yeah, exactly. Yeah. So we did the addition algebra rules. This is the, I think they call this the constant rule, right? Or is it called like linearity or something sometimes? Yeah, exactly. Okay. Oh, well, this is just a product rule, right? Because, again, nabla is just taking derivatives and different types of derivatives, but then assigning them to coordinate systems, right? So I think this is the same as grad f g plus grad g times f. Yes, Infinite Void. I can definitely explain Taylor series. Taylor series are really cool. I know they sound scary, but I really like Taylor series. If you want to submit a screenshot, I'll do it later in the stream. Okay, I think this is true. And then that would also mean by the quotient rule, right? Grad of f over g would be grad f, or I guess g grad f minus f grad g all over g squared, right? Okay, cool. So I think those are the general algebra rules, right? Yeah, the quotient and chain. Oh, the chain rule applies too. Oh, interesting. So, if we do f of g, right? F of g of whatever, f of g. This is the same thing as what's that gonna be like? Grad f times grad g, kind of. Well, I'm trying to think how this works. How do you get numbers from letters? Well, you usually assign you assign numbers to the letters. Okay, yeah, good. Grad f of g times grad g. Yeah, I agree with that. Okay, it's this. Yeah. Cool. 6. What's 6? Oh, that's how you get numbers from letters. That box. Okay. Cool. I think we established the algebra rules for gradients. Cool. Whose question was that? That was River. River, why'd you dump like 12 screenshots? Jesus, River. Yeah, it's pretty much the derivative rules. Yeah, was that Jeb's question? Yeah, that was Jeb. Okay. Please clap. Please clap for Jeb. All right, let's see. Ben already, I think, has a So Ben, I think you are getting help here because Costa is typing right now. Yeah, Costa's typing. Bless you, Costa, for typing something. Femvox has started typing something as well. This looks very interesting. Yeah, dude, this is all kind of like Spanish to me, dude, or Chinese. Nice. Okay, cool. So 67, nice. Where's the 6-7 coming from again? Wait, is there a 67 somewhere? Got it. Where is it again? Alistair, I can definitely help you with linear algebra. Please, yeah, feel free to submit it. Jay says, any tips on understanding second derivative tests and how to find critical numbers? Yes. Critical numbers is where the first derivative is equal to 0. And then the second derivative test, if it's positive, tells you it's a local min, and if it's negative, it tells you it's a local max. So this was Jeb. Let's post that. And let's see. Ben already has some submissions. Oh, can you help me with the units because I'm from the EU? Yeah, okay, Costa. So I think they use square inches and pounds. Okay. Ellie DeGoat, and if it's negative, it's a saddle. No. So Logan, that's different. Sorry. If we're talking about like critical points for multivariable things, then you have to use what's called the Hessian. I did a question on this, so I did this today. That's what this was. This was earlier in the stream, and this is kind of the rules for what the second derivative has to be to classify as something being either like a min, a max, or a saddle point. If you want to see like where that got done, in the Discord here, which thank you, Costa, for helping Ben out. I think this was JH's question. So here, this has like the solution to how I did it as well. Yeah, PSI and KSI. Yeah. Ellie says, what are things you can use? Yo, is Stucky here? Yeah, what's up, Eric? What's going on, Famish, dude? What are the things you can use algebra for in linear algebra? Wait, algebra for in real life? Oh, dude, algebra gets used for everything. Yeah, there's so many examples of algebra being used in real life. I mean, just for instance, just figuring out whether something's more expensive. Like when you have two competitors, and a lot of times they have like variable initial charges, but then they have other like charges based on like a rate. So like rentals are a big thing that happens. A lot of times a company will be like, oh, hey, we charge $200 up front, but $40 an hour. And then someone will be like, oh, we charge $100 up front, but it's $80 an hour. You can figure out based on how long you need the thing, which company you should go with. So. Oh, you were live and Stucky showed up? Yeah, I need to talk to Eric actually about math stuff. But I will schedule that. I have to talk to, what is it? Zach. Yes. Zach, if you're here. Awesome. Okay. Hey, I'm in Calc AB right now and want to be moved. And my teacher said if I want Calc BC, I will need to take the Unit 4 exam in 2 days. And AB is only on Unit 3. So how do I self-teach Unit 4? Well, what is Unit 4? That would be helpful first, Laplace. What do you need to know for Unit 4? Jay says, thanks for the help this semester. It's my first taking calculus in college. Wow. You're very welcome. Good luck with I mean, I love Calc. Calc is one of my favorite classes to teach. Because I think there's more of a coherent story with calculus compared to, like, I say pre-calc. It just feels like a grab bag of, like, random stuff. Oh, this is a fun one. Oh, someone's going to mess me up with this one. Oh, related rates? Yes. Okay, so mainly related rates. Okay, so Laplace. You basically need to learn, applications of derivatives. You mainly need to learn a little bit of physics, I guess, for velocity and position. But related rates is very important. I have a video on it if you want. So if you go to my YouTube, which you're watching me on YouTube, so I should be able to get to my YouTube pretty easily, right? You know the physics part? Great. Then you're fine with all that. If you go to like here, if you type in related rates, I have this question: how to solve related rates in calculus. Yeah, here we go. Well, so this is the full version, which is 1:48, and then all my shorter shorts do better, but whatever. Here. I now get advertisements on my own videos because we just got monetized on YouTube. Which, like, I'm happy about that, but also, like, unhappy that now they force me to watch ads on my own stuff. Yeah. So, there you go. There's a video on that. Or there are probably other YouTubers that do stuff that are great. I gotta watch that movie. Is it Alien vs. Predator? Is that what we're doing? Okay, let's do this. Evaluate the integral by changing the order of integration in an appropriate way. Ooh, so this is kind of a multivariable question. So let's try to talk about what the bounds are here, right? If I can like kind of draw what this is, then it becomes a little easier for me to see things. Oh, it's Predator versus everyone. Oh, that's fun. So dz, dx, dy. So that order tells me that this is corresponding to z, this is corresponding to x, and then this is corresponding to y. No, it's 3D Laplace. It is, yeah. Yeah, this is multivariable. This is Calc 3. So this is beyond Calc BC. This is like the next year of calculus you take in college. Okay, so z is going from 0 to pi. Cool. And then x is going from y to 4, I guess. And then y goes from 0 to 4. Yeah? Okay. Can I try to draw this in 3D? Maybe. We'll try to think about it, right? Let's draw a little axis here. So X, Y, Z. So Z is going from... I always like to go with the outside one first to see what's happening. So Y is going from 0 to 4. Cool. Okay. So that tells me from here to here, right? We're definitely integrating from 0 to 4 in terms of Y. No way you're trying to draw it. I'm going to try. Because then here's a cool thing. X is going from whatever the Y coordinate is to 4. So this tells me this is between, X is going between, I want to say like X equals Y to X equals 4. So if X equals Y, that's the same as Y equals X. So that ends up looking like this, right? This is like Y equals X. And exactly, and then, yeah, Jeff's exactly right. Then in the Z plane, we're just going to put it up to pi, which is beautiful. So X is constrained. So as we're traversing Y, X needs to go from Y to 4. Okay, cool. So that tells me that this area is getting integrated, right? So as I'm, and I like to work from outside in. From outside in, as Y is going from 0 to 4, my X coordinates need to span what the Y coordinate is, which would be here on the line Y equals X, and it needs to go over to 4. What's up, Name? Thanks for calling me the GOAT, dude. I appreciate it. And then Z just goes from 0 to pi. Okay, cool. And so then it's just a solid thing like this, right? Up to pi. We agree with that so far? Yeah. So it's like a triangular prism. It looks like a piece of moon cheese. I definitely could, Mohammed. Yeah, submit a screenshot to the website. Actualofficehours.com. Just submit a screenshot there. I'll do it. The queue is not 11 questions. River just dumped in like a ton of them. River, what are all these questions you dumped me, by the way? Let me just see them real quick. Resistor codes. Oh, you just dumped the same image like a bunch of times or whatever. All right, I'm going to clear all those real quick. I'll see them on the other thing. Just so people don't get like scared at the queue being like too long. Yeah, cool. All right. Good, nice. Good, Ari. Okay, let's reorganize this. So why do I want to reorder this Okay. I think the reason I want to change the order of the integration is, let's see. Well, the integral of dz is actually very easy. Oh, wow. Thanks for the raid, Obi. What's up, dude? Good to see you, Obi. I think that's not too bad. But then I see where this probably gets bad. The integral of sine of x over x dx from 0 to... Yeah, that integral probably sucks. How is everyone doing? We're doing great.
I just got back from... yes, and now I got the baby voice. I just got back from TwitchCon this weekend. It was really fun. Great experience. Had a blast. Okay. So, I don't really see an issue here of the 0 to pi. I'm going to leave that dz. I think I'm going to switch these. Can we switch these bounds, you think? Fembox, is that probably like the nicer way to do things?
So, I'm still going to go from 0 to 4 in terms of x. So I'm going to say 0 to 4 in terms of dx. But then here, my y coordinate needs to go from 0 to x. And then I can still do from 0 to pi dz. Yeah? Is that I think that's still like an appropriate change of bounds, right? Because as long as you're still encompassing the same area. So we're still encompassing 0 to 4 in terms of x. Y is going from 0 to x. And then z goes from 0 to pi. Long division. How do you factor out the z and y integrals now? Well, we'll see. Let's just do it. I'm just curious. I mean, the integral of sine of z dz, this stuff doesn't depend on z, right? So this is like a constant. So the integral of sine is negative cosine. So now we have 0 to 4, 0 to x, and then that's going to be negative cosine of z. Sine x over x. And then this is a value, and we still have dy dx, so we still have to eventually do. But this is evaluated from 0 to pi. So negative cosine of pi is negative 1. And then it's 1 minus 1, so it's 2. So I think this pulls out a factor of 2, yeah? Yes, I can definitely do I love Lewis structures. Yeah, please give me Lewis structure questions. I love those. Those are fun. So I think this is just going to be 2, 0 to 4, 0 to x. And then that's going to be sine of x over x, right? And then we have dy dx. Here's the cool thing. Yeah, watch. Because now when I do this integral with respect to dy, notice how there is nothing there. There's nothing in terms of y. So the integral of that is just going to pop a y in. So now I have 2, 0 to 4. And now this is going to be sine of x over x y evaluated from 0 to x. I love this. Because now with my bounds going from 0 to x in for y, that's going to cancel this one out. Oh, that's so cool. I think I'm doing this right. You tell me if I'm doing it wrong. I'm pretty sure I'm doing it right. So that's going to be 2, 0 to 4, sine of x. Right? Because then this is technically like x minus 0. over x dx, but then like, so this all goes away. Yes, also true. There is a minus 0, but I mean the 0 just goes away, Obi, right? Okay, cool, Perry. Perry, can you take a screenshot of that? I mean, I can do it for you too if you want. It might just be easier. One sec. I just want to add it to the queue for you. One sec. Let me think how to do this. Yeah. There's your there's your question. And then here, let me get the snipping tool. You like it? I like it too. Here, let me get that. Let me save it for you. I'm just gonna show so people can see how this works. I like to draw things. LOL. That's kind of what I did. That's kind of what I did here for this question. Is I tried to draw it out and kind of, but I would say start from the outside and then work your way in. So for instance, here I saw that y was spanning from 0 to 4, and those are just numbers. So I know that my y stuff needs to go from here, y equals 0 to y equals 4. And then I look at the next thing in, which is dx. I'm like, okay, well, but x, so as I'm traveling from 0 to 4 in terms of y, my x needs to be bounded from y to 4. Which, this kind of tells you, oh, well, it's bounded along the line y equals x up to 4. But visually, right, you can see that, okay, well, if my x is bound from y to 4, that means whatever my y coordinate is here up to x equals 4. And so that gives you, like, the bottom half of this triangle. Instead of it being, for instance, this part of the triangle. Yeah, so it's not this part of the triangle, right? It's this part of the triangle. Law says, I study pure math, so my questions usually give me a plane to bound things. Oh, okay, so then that's just, like, really difficult to visualize.
You done messed up, AA Ron!
Yeah, okay. I'm not sure exactly then in that case. Maybe one of the guys here would be able to help. Okay, so let's just do this integral real quick. Okay, integral of sine of x is just negative cosine of x. Cool. So I get 2 negative cosine of x evaluated from 0 to 4. So that's going to be negative 2 cosine of 4 minus, right? Because, wait, no. Cosine of 0 is 1, minus 1. Okay, so then it's plus 1. Okay. Is this what you had, Fembox? 2, 1 minus cosine of 4? Yeah. No, wait. Oh, and then there's another 2 on here. Sorry. This is plus 2. Yes, so 2, 1 minus cosine of 4. Nice. I agree. Great. Good question. Cool. Whose question was that? That was not this one. Not my pictures. Just use exclamation point submit. So that was Ari. So I'll show you how this works. So for instance, what was it? Perry, you had a question here. So you would go to this website, actualofficehours.com, type in your username that you want me to see. So Perry. And then you would drag and drop in your question. You would hit upload. And then it should say it was received. Cool. And then you can always check, because if you go to the live queue here, you can then see what the queue is at. And so you can click here on Perry's question, and there's his question. Cool. But this was Ari. So let me put this in our Discord real quick. And then this was... Wait, I didn't get Ari's yet. One second. Let me pull this down. Sorry. Ari. Cool. You can see them later if you want. That one should submit at some point. Okay. Next one would be Abdallah Star, but I think Abdallah told me he left. He said it was 2 a.m. for him. Oh, also this is in German. Oh, he's in Vienna. Oh my god, dude, what are these questions, dude? So, hey, I'm first being challenged by the fact that I don't speak German. But very cool. Okay, but all right, he left, so we're not gonna do that one yet. River, I will do yours. You can speak German. Very cool. Let's see, River. What did you want to ask? Did you send me? You send me something else? I'm waiting for it to load. Determine the resistor. Oh, you dropped a lot of stuff in here, dude. Let me see. I love you, but I don't know much about moving wobbles. Technical German as well. Yes. Famish says I can speak English. I can speak English sometimes. True, right? Okay. There's a lot of like fun circuit questions in here. River, you want to tell me one of these questions you want help with maybe? I'll do one of them. Like maybe I'll do one of the circuits one. I think the circuits ones are cool. So, do you want to help with this one, for instance, River? Is this it? How often do I go live? 5 times a week. If you ever want to know about our schedule, if you go to that website, actualofficehours.com, there's also a link to a Google Calendar. Right here. So if you go here to streaming schedule, click on this. This will show you the current schedule that we have, as well as our friends. Oh, wait one sec. Why is my internet like... It says, bro, no, that one's easy. Well, okay, maybe. A question with a transformer. Well, none of them really have transformers. Oh, we're dropping a lot of frames today. Oh, dear. Internet. Anyways, this has our calendar of like when we stream. So Zach's another friend of ours. He does a lot of math and science streaming, or sorry, a lot of math streaming. Sorry. He does stats. He does some sciences. But tomorrow he's doing math chat on a topic. If you want to come by his stream tomorrow morning, and then we'll be doing free tutoring again starting at 4 o'clock Pacific. So that's where you can find it. Let me just do this one. Just to get the ball rolling. Circuits are cool. With cylindrical coordinates. Uh-oh. You're gonna hurt me, lol. Alright, here we go. Key thing here is... this is a very simple circuit. So this tells me we have 90 volts going across here. Great. Whenever you see circuits with multiple components, you want to try to reduce it to a circuit of just like one component, right? So, an easy one for this would be to combine these two resistors together. These resistors are in series. So I can come up with a new resistor, R12, which is going to equal R1 plus R2. And so that would equal to 30 ohms. This is definitely with Ohm's law. 100% this is with Ohm's law. Yeah. Okay. So now my new circuit is this. This is 30 ohms. This is 90 volts. And then this is very simple, V equals IR, right? So 90 is equal to I times 30. That tells me there are 3 amps running what its more complicated circuit was. And what we know is that for things in series, they have the same current as what they did when they were a super resistor together. So this will have 3 amps across it. This will also have 3 amps across it. Okay? So if they want to talk about I1 and I2, that's all going to be 3 amps. Okay? If we want to then figure out the voltages of these things, those are going to be different, but that also comes from V equals IR. And so in that case, that's going to be this current times this resistance. So this ends up being 60 volts. This ends up being 30 volts. It's Kirchhoff's loop law, because the voltage drop across this resistor plus the voltage drop across this resistor, so 30 volts and 60 volts. This is how you can kind of verify you did the right thing, is that the voltage drops across things in series should also equal the voltage drop across what the super resistor thing was. So in this case, you dropped 90 volts across it. You dropped 30 and 60. Great. I don't know what RT and IT means. Maybe total resistance. Oh, well, total resistance was 30 ohms. And total current was also 30. It was 3 amps. Nice. That one's not too bad. If you want to see, I can maybe do a resistor one for you. These are fun. And then here, let me post, yeah, there's a lag, unfortunately, Femvox, on Twitch right now. Okay, and then let's try to see this one. Gold. Okay. This is why, yeah, whenever you see resistors, it's kind of cool. They have all these different colors on them, and the colors mean different things. So, for instance, here, I guess it's a number is what it is. Yeah, so orange. So that's going to be 3. The second band is gray. That's going to be 8. Then the next band is going to be black. That's 0. And then the fourth band, gold, that determines the multiplier. In this case, they're saying that 380 times 0.1. Oh, okay. So what is that? That's just 38 ohms? This is resistors. I'm pretty sure that's what it is. Should be. Okay. Cool. All right. Good job, River. Download this. River. Yeah, you're welcome, River. Why are you learning circuits? Circuits are cool. I really like circuits. You hate them? Ah, dude, circuits are so cool. I don't know. I'm a very like hands-on person, so to me. You can just tell me if you don't want it in there anymore. So right now I have... Yeah, I don't really like the engineering stuff as much. Yeah. Okay, so the next one is honey. Shown below. Determine the equivalent force couple system at point A. Also find the location of an equivalent single force along a horizontal line from A. Oh, Jesus. How to join the queue? Oh, there. Actualofficehours.com. Just go there. And you can submit a screenshot to go over on the queue. This one, these all look just like ugly as fuck. I feel like I could do this one. I like this one. This one's great. An angle bracket. This is super fun, actually. Dude, maybe number 4. Well, okay, but now you guys are talking about moments. I don't like these moment things. I guess it's torque, right? Is that what we're saying? It's torque? The figure to solve that is 4. Wait. It's the same units, damn it. Okay. I want to use... well... They say the equivalent force about point A. So here's my question. Sorry, what? Is this related to this? Like, for instance... It is separate. Oh, okay, cool. Then what was the question even asking for, dude? Sorry. Determine the force couple system. I don't know what a force couple system is. Y'all with these engineering questions. They put all these fancy words on things, dude. I guess, and what's the moment on A? Okay, I could see that. Okay. So then maybe you guys can help me here. If I wanted to define what this moment was, let's say for this one, right? This is... So that would be equal to what, like 26 Newton meters? Yeah, it's lagging a bit. It'll get it. It'll get it. Give it a second. My face is teleporting. Oh, dear. You need the other ones as well. Okay. So, I mean, that's from that, right? So, we can do a couple things, right? I can do sum of forces, and then I can do the sum of torques, right? That's how I want to see this. From again, coming from a physics background, I like doing this. Sum of physics and sum of torques, right? So, here, that tells me I have, in terms of my moments, my torques, right? I have 26 Newton meters going to the right. And then I have plus another 50 from here. Oh, because it's static. Okay, cool. I mean, torques can be static too. And then we also have torque from here, right? So this is also going to provide a torque, which is going to be equal to 150 times 0.3. So that's going to be equal to 45 Newton meters, right? The force would be negative. Yeah, I haven't done the forces yet. I'm just doing the torques, or I guess the moments, as y'all call them. We live in a... Okay, here's the cool thing, though. This provides, right, a moment that goes in the opposite direction, yeah? Right, this provides torque that way. And that one's equal to... Okay, if this is a 3, 4, 5, cool, and this is 150. This is, again, where Pythagorean triples come into play, right? That tells me this is 120 newtons down. And then 30 newtons to the left, right? It's kind of cool how that works. Okay. So then that moment is equal to 120 times 0.150. Which, what is that? Is that like 18? 18 Newton meters? Oh, 90. Sorry. Yes. Sorry. I multiplied by 10 instead of 3. Sorry. Thank you. Yep, that's 90. Good. Yep. Okay, cool. Okay, I think we got all the Femvox says he got 103 counterclockwise. And I think that's what I'm going to get. 76 plus 4. Let me get a calculator. 76. Sorry. Ooh. 76 plus 45 minus 18. Yes, good. I get 130. Yes, cool. Okay, so 103 Newton meters. And then, yeah, counterclockwise. Okay, this is cool. Corvette said it also said to find some distance. Yeah, well... minus 90. Good, so that's 290 newtons left. And then in the y direction, you have 150 minus 120, which is 30. 30 newtons up. Cool. All right, I agree with some of forces. All right, then let's see. What was the question asking for? So Femvox says, and the single force should be located 103 divided. Oh, 103 and then 30. Where are we getting the 103 from? Oh, from this. Okay, torque and statics is the one that will twist. So the resultant force. So 290 newtons this. So that's the direction of the force, right? But then I need it to produce this moment. Correct? Right? Whoa. I think I know how we do this. Of 30 over 290. So that gets me 5.96 degrees, right? And then this resultant force, right? Would be 30 squared plus 290 squared. Oh, sorry. And then we're going to square root that. So that's going to get me 292 newtons. Okay. Now, Femvox, I think what I need to do is I need a single force of 292 newtons to also produce the same moment. That's what they want. Because what was the required moment? 103? Yes. Okay, so 30 times x has to equal 103 newton meters. Right? Because we're thinking, all right, if this force is acting at some distance along the x, so yeah, so x is equal to 103 over 30. So that's equal to, yeah, I don't know, what, like 3.33 meters, I guess, right? That's very far. Exactly, right. So, yeah, what you would do is you would take this force, you would put it, and you also have the same the moment that you need. That is a really big number, yeah. But I do think it's correct. I mean, I think we did this right. Unless I have maybe my zeros are off. Sorry, 130. Yeah, 26. Yeah, no. Yeah, Fem, we're correct. I'm pretty sure, right? Yeah. Mm-hmm. Yeah, I think we're right. Yeah, it's just a big number. Okay, cool.
My man.
Cool question there, Corvette.
Well done. Well done.
Yeah, you're very welcome. Yeah, so here you go. Say, Corvette. Bum, 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 bum. Still dropping so many frames. All right. I need to go talk to my IRL streamer friends and figure out how they're doing that. I need the bandwidth. I'm getting very frustrated that I can't just find like a fix for bandwidth in my... Oh, it's because the net force came out to be almost horizontal. Exactly. Yeah. Yeah, there was like no net vertical force. Okay. That was Corvette's question. Which, your name was Honey. Okay. So let me maybe edit this, sorry. Alright, that one's done. Next up is Jeb. Oh dear. Bing. It's my first day back streaming. Let me make sure, sorry, when is my next student I have to teach? Oh, we still got a little bit of time. Okay. Above, by the plane. You did good on your... Correct me if I'm wrong. I'm pretty sure that's what it is, yeah? I just know that because I've seen this question so many times. Maybe to find vectors, like this vector and this vector, and then like find a normal thing, and then like whatever, plug in a point. I think it's just x plus y plus z is equal to 6, though. Right? Because if x is 0, y is 0, z is 6. If x is 6, y is 0, z is 0. Right? Yeah, this is my bandwidth like fucking up. So hang tight. I'll be back in 5-10 minutes.